also we have a requirement for major water using businesses, those that use more than 10 megalitres an annum, to achieve best practice water efficiency or to reduce their water consumption by 25%. What we've seen is a number of those businesses in South East Queensland are using stormwater harvesting as a means of achieving that guideline. Final driver for me is the increasing bulk water prices. Essentially what it means, the cost of water will go up over time to pay for the security of the South East Queensland water grid provides. What that means when you're looking at the cost effectiveness of stormwater harvesting compared to alternative sources, things that weren't cost effective or didn't compare 3 years ago, 5 years into the future may very well be cost effective. So taking that theme, the Commission and worked with the Healthy Waterways Partnership to commission a report about a year or so ago that Bly Tanner did for us. And the purpose of this report was essentially to look at a sample of new development areas and to work through whether stormwater harvesting could be used to achieve that water savings target and the water sensitive urban design guidelines more cost effectively than doing the two requirements on a standalone basis. So is it more cost effective than rainwater tanks and detention basins? And what that study found is, depending on the site, it can be. There are a number of variables that affect it, but particularly on large sites and sites where you have land that is available for the storage, it certainly can be a cost-effective solution. What those variables came down to is in terms of the slope, and the first one is the land and whether you can cost effectively find the storage and to actually maintain that water in to be able to use it when you need it. Beyond that, but there is a question of what is the catchment area that you have that can actually supply the scheme. So a number of the demonstration projects that I'll talk about have the advantage that they actually have a catchment that is larger than the development area itself. Another key variable is slope. Too little slope doesn't work well, too much equally can be a problem. And so the study was recommending that somewhere between a 2% and a 10% slope work best. The high environmental values is a driver, and the key reason for that is the water sensitive urban design guidelines and the requirement, particularly on some areas, that you capture the first 40 mils of runoff and that you don't, that is used elsewhere. And the other one is, what is the demand? So a high demand for non-potable water obviously lets you empty the storages quicker and therefore makes the yield higher. The next stage of what we've been going through is taking those conclusions in that study and looking at promoting a number of demonstration projects across the region. What we're looking at doing is really harvesting from an existing stormwater drain through the South Bank site into a 2 megalitre storage. From that storage, the water is treated through a filtration system and disinfection system and is used within the South Bank, or will be used within South Bank, for the irrigation in the first instance and for toilet supply, and depending on the water quality and how that's maintained over time, could in the future be used for supplementing their pool. The project's being developed as both a demonstration project but also a project that people can look at and is being designed with the plant filtration particularly to be visible for visitors to the centre, to be able to look in and actually see how it works. I think in the interest of time I'll move beyond that. I think the key thing is this is a pretty sophisticated treatment system with microfiltration and disinfection within it. The details of it, David and Chris Tanner, who are involved in it, can speak to after if people have more questions. In terms of funding, the total cost is in the order of $9 million. The Queensland Government's paying $4.6 million for it. Another $3.3 million is being paid by the Australian Government through DUHA. It has raised for us a number of institutional arrangements we needed to work through. One of them is who owns the water going down the stormwater drain and what is the basis on which South Bank can actually tap into that and take that water, and how do we manage the upstream flooding risks of actually having a barrier constructed within that pipe. The scheme is under construction at the moment. It's due to be completed in December and commissioning starting early next year. The second project that we've been focusing on is at Fitzgibbon, and the importance of this one for us is that it's an example of using stormwater to achieve that water savings target. So it involves using stormwater for non-potable purposes within dwellings, both detached houses and medium density houses. It's been the feasibility studies for the Fitzgibbon Chase project, which is a Urban Land Development Authority site. It involves about 114 hectares of land and about 1,800 dwellings. The way this scheme works is that there is a 290 hectare catchment upstream of the Fitzgibbon site. Within the site themselves there is a diversion pit where stormwater could be harvested from the creek and stored in a storage on the top of the site, which is under a Powerlink easement and an Energex easement. So going back to the advantages and where stormwater harvesting stacks up, this is a site where there was land available because it couldn't be developed being under the easement. From there, it is being distributed through the pink area, through a dual reticulation system into toilets and into washing machines. Again, the treatment system on this scheme at the moment is microfiltration with disinfection, and one of the key parts that we're actually really interested in is using it as a research project over the next few years to monitor what is the quality of water coming into the scheme, what's the efficacy of the treatment process and how can that be adjusted, what's the quality of water coming out of it. So I'll speak later about the Urban Water Security Research Alliance, but within the project bid to the Australian Government, there's an allowance of about $600,000 for that monitoring program. In total, that stream has on average about 4,400 kilolitres a day of flow. What we're talking about in a diversion in this is about 290 kilolitres of that, so about 6% of the flows down the creek. We've completed, in terms of where it goes from here, the feasibility study's been completed, and where it's interesting as a first stop for us is it shows how stormwater harvesting can be used to achieve that water savings target. The next stage is we're investigating ways of getting funding for the development to proceed and to incorporate this within it. The ULDA is willing to contribute something towards it, but they are looking for funding, some funding at least from the Australian Government, and a submission's been made for that. I mentioned earlier the other driver being the water efficiency management plans. There's a number of sites and businesses around southeast Queensland that have done stormwater harvesting as a result of that. One of the ones that we've particularly highlighted before is the Lone Pine Koala Sanctuary. They, in 2005, used about 30 megalitres of water. What they've done as a result of the WEMP program and during the drought is looked at ways to reduce that use. Stormwater capture is a key element of that. So they've got a 200,000 litre water tank. Again, they've got sediment filter and UV treatment, and it's reduced their consumption in the last year to about 4 megalitres. So between that and reuse within the site, they've had a major savings, and it's been, for them, the most efficient way of achieving those water efficiency management plan standards. One of the issues we have, but is that there actually is an absence of information on a few grounds about stormwater harvesting and where stormwater harvesting would work. So the state has established what we call the Urban Water Security Research Alliance, which is an alliance with the state government, CSIRO, the University of Queensland and Griffith University. It's been funded to $50 million over a 5-year period, and stormwater harvesting is a key aspect of what the works that they're looking at. One of the first things that is being done for stormwater harvesting is looking at what the impact of stormwater harvesting is on the ecology of local streams. Whereas there's been a lot of work done for rivers through the water resource planning process, there's a lot less knowledge about what does it mean within urban areas. So they're going out through this program to 25 different catchments within Brisbane, and using a set of environmental parameters very similar to what is used by the Healthy Waterways Partnership for the major rivers in the Bay, and matching that with detailed stormwater management, stormwater modelling to look at the different levels of urbanisation and to calibrate models. And using those models, they'll look at testing different scenarios of what varying the flows down those creeks will do to local ecology and what those potential impacts could be. The second element where there's a lot of debate Australia-wide is what is the appropriate level of treatment for stormwater harvesting? How sophisticated do your treatment processes need to be? When I explained those case studies before, they are both fairly sophisticated treatment processes. They require a high level of expertise in risk management and operation.